Hi everyone. Right, today we are going to be doing resistance. In the previous two lessons, we did current and voltage. And so now we are doing resistance. I went over a couple of equations in the first two. Now what I'm going to do is, but I didn't do any calculations. Now I'm going to do another two equations, just the resistance equations. We're going to do some calculations. We're not going to do any voltage or current calculations. That we will do in the next lesson. So this time I'm just going to teach you how to calculate resistance in parallel and resistance in series. So let's do the equation for R series first, because that's the easiest one. So R series is equal to R1 plus R2 plus R3 plus blah, 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 blah. Because you could have a number of resistors. So then the second equation is resistors in parallel. And that equation is 1 over R parallel equals 1 over R1 plus 1 over R2 plus 1 over R3. So parallel resistors, those are these ones here, the 6 ohm, because you can see the parallel lines connected in parallel. Now, what I want to do is I want to calculate the total resistance of the circuit. Because if I can do that, and they give me the voltage coming out the battery, that would allow me to work out my current. So the first thing I want to do is I want to calculate the resistors in parallel. And the reason for that is because then, if I calculate the total resistance of these are the 6 ohm and the 4 ohm resistor, I can then treat that as one resistor, which will then be in series with the 2 ohm and the 7 ohm. So let's do the R parallel quickly. Okay, so using the equation 1 over R parallel, we get 1 over 6 plus 1 over 4. Okay, which I then convert to 2 over 12 plus 3 over 12. I could also, if I've got one of those calculators with a fraction button, just put the 1 over 6 plus the 1 over 4. But let's do old school. Let's work it out. So that equals 5 over 12. Now that's 1 over R parallel. Now, we mustn't forget, we need to flip that around because I've got the 1 over R parallel. So to get R parallel, I flip it around and it becomes 12 over 5, which is 2,4 ohms. I think I might have COVID-19 because my brain is, yeah, it's not working too well today. Okay, so now I've got this is now combined to be 2,4 ohms. So I'm going to do that in purple. Now this is 2.4 ohms combined. If you look at the parallel resistors, they're always going to equal a smaller number when you combine them than the smallest resistor. And that's because if I've got a 1 ohm resistor and a 10 ohm resistor, that most of the current is going to go through that 1 ohm resistor. But the resistance is going to be even less than the 1 ohm because now you've got 2 paths to travel. So just bear that in mind. Okay, so now let's do the resistors in series. So we've got R series equals, and it's going to be 2 plus 2.4 plus 7, which is 11,4 ohms. And this is my total resistance, R total of the circuit, is equal to 11,4 ohms. Okay, so I'm going to, for the next lesson, we're going to use this value of R of 11.4 ohms to be able to calculate the total current in the circuit, and therefore we would be able to do the voltage readings on each. But that's all for next time. So yeah, resistors in series, we see that if you add more and more resistors up in series, the resistance goes up. More resistors in series, a bigger amount of resistance. But if I put them in parallel, it's just more paths to carry. So the total resistance actually comes down. So just keep that in mind and have a fantastic few minutes. We'll see you in the next lesson.